Hello, everyone. Welcome to the Carolina Weather Group. This is the May 17th, 2017 edition, right at 8 o'clock. Good job, boys. We're on time tonight. Welcome to the Carolina Weather Group. We had a little break last week, a little spring break, so hopefully you didn't miss us too much. We were able to catch up on some things other than this, but excited to be back with you again tonight. A lot of things happening in the area over the past couple of weeks, so we'll quickly recap those before we go into tonight's show. We are talking about the tropics. A couple of weeks from now, the official start of the 2017 tropical season. Levi Cowan is our guest. You probably know Levi from Tropical Tidbits, but he also is excellent, has some expertise in tropical meteorology. So looking forward to getting with Levi tonight and kind of talking about what to expect in the upcoming year. As well. So if you're watching tonight on the live broadcast, or if you're listening to the podcast a few days from now, you can tweet us your questions at Carolina WX Group is how you can reach us on Twitter, and also on our Facebook page. Be sure to send those questions to us, and we will get to those tonight. And if you are listening on the podcast, we'll let Levi share his social media information towards the end of the show so you can connect then. So I guess, guys, that's about it for for all of that. It has been quite an active period over the last couple of weeks. I'm going to toss it over to Ricky Matthews because I think Ricky was the only one in our little panel here that actually experienced a tornado in his forecast area. So, Ricky, it's been pretty active over in East Tennessee in the past couple of weeks.
We finally did it. After 2.5 years, we finally did it. We broke the streak, 1,020 days without a tornado warning in the Tri-Cities television market, which includes Southwest Virginia, Northeast Tennessee, and 2 counties in Kentucky. And we broke that streak on May 12th. Kind of an interesting event, guys, because we really were not expecting tornadoes. We were in like a general thunderstorm risk area. All the forecasts that morning kind of really didn't have anything in there. But if you go back and look at the mesoscale analysis of that day, we had a wedge situation across North Carolina. And Scotty can tell you what wedge situations usually do across North Carolina. They cause some fun zones of increased helicity. And that's what I think happened right in Johnson County towards Shady Valley, which is just east of the mountain chain there of the Appalachian Mountains as they run down from Virginia into Tennessee. The Weather Service and I both believe the tornado the storm came off the mountain. And we get something called vorticity stretching, where the vorticity kind of increases, spin increases in the storm, and we can sometimes get a quick little tornado. That happened, the Weather Service believes, in the Camp Creek tornado back in Greene County in 2011 on April 27th, and probably in the Big Stone Gap tornado too, which I think was in 2009. So yeah, interesting day. It's always fun when tornado warnings happen at 2 o'clock in the afternoon, in between the morning and afternoon shift changes, the TV stations where no one's around to help out and you don't expect it at all. And 3 of your 4 meteorologists aren't there, and the one who is there is editing a package. And it was a fun day. So, and I'm sitting at the airport in a totally different state, an hour behind, trying to update social the best I can, and then tweeted all my tweets in Central Time instead of Eastern Time. So there was that. So fun times up here. Officially rated an EF0. It lasted on the ground for like 8 minutes, but we got some cool drone footage afterwards. That was kind of neat. First time being able to take my drone up and survey some tornado damage, Scotty.
Yeah, Ricky, it looked like it was an exciting time. I was able to catch Chris Michaels do a little bit of the live casting there. So I know you guys, it's been a while for you. So glad to shake some of the rust off for you.
And I got to say, Chris did a fantastic job for being by himself and, for never covering a tornado in our area. He did a fantastic job for what we were thrown our way. So.
Definitely. You got to love those in-between times. So I do think, Ricky, we'll mention this too before our last show. We actually had some more severe weather outbreak in North Carolina. This was May the 6th, I believe. The several tornadoes that touched down in the Greensboro and north into the southern Virginia area as well. That was actually May the 4th, not May the 6th, May the 4th. But so again, it's been kind of active here in the Southeast, severe weather-wise, until this week.
And the interesting thing about that system too is it was very low-topped supercells. Really, I looked at the storm that moved over Emporia and then moved up towards Waverly and Wakefield, and that storm had like a 9,000-foot top on it. it was not anywhere close to being what you would consider typical tornadic type thunderstorms. It was almost, you weren't looking for that, but there was a lot of shear, right ingredients came together. And it was almost like, it reminded me a lot of a tropical setup, where we get those very low topped storms that can produce quick spin up tornadoes. Don't really last for too long, but it was reminded me of a tropical setup for sure.
It wasn't. Unfortunately, those tornadoes happen in the dead of the night. I think 1:30, 2:30 in the morning.
Well, we had some in the morning across eastern North Carolina and eastern Virginia. And then we had another round in the afternoon that came, and then you're right, there were some in the night too. So it was really like an overnight into the morning and then into the next day of the afternoon kind of deal. So not like Oklahoma for sure.
No, not at all. And as we say that, our thoughts is with everyone in Oklahoma, especially Elk City, looking at some of the survey damage, possibly EF2, EF3 tornado that touched down out there as well. So let's go down to Charlotte, North Carolina. I'm going to pass it down to James. James, was you hot today? It was kind of hot here. I know it was probably hot there in Charlotte as well.
It was hot outside today. I think we crossed the 90-degree mark here in Charlotte, if I'm not mistaken. But what was more concerning to me is the fact that even at this hour right now, it's like 80 degrees in my room here, in the entire building. I'm walking around with one of these to try to stay cool, and I'm very concerned that if this is what I'm doing in May, I'm afraid to know what I'll be doing in July. So if anyone out there services air conditions, give me a call.
Yeah, and then you can sponsor our show.
Yes.
I mean, there you go. All right, well, thanks, James, for that update. Let's go up to another place where it's hot. And Ricky, I think we were talking about this before the show started, and I know David just joined us. So, David, looks like it was hot up there in your area as well, in the Charlottesville area.
Yeah, we made it all the way up to 93 hot degrees this afternoon, 2 degrees shy of a record, at least at McCormick. However, at Cho, which is only has records back to November of 1998. So we've only had, 18 Mays so far in the book. Well, on the 17th day of May, the previous record at Cho was 82 degrees, and we hit 93 today. So, yeah, it was hot. We're forecasting another hot one tomorrow. Backdoor cold front gives us some relief as we head into the upcoming weekend, which is final exercises for UVA. They don't call it graduation. Thomas Jefferson believed that they should be called final exercises. That's a fun fact that I had to learn. And it's also called grounds here. It's not campus, it's grounds. But yeah, beautiful weekend ahead. And then we have another batch of rain coming in Monday. And other than that, pretty warm today compared to the 50s we had this past Saturday. So talking about temperature swings.
Did you see where Williamsburg hit like 95, 97 degrees today?
Waynesboro?
Williamsburg, Virginia. Colonial Williamsburg.
Oh, Williamsburg? Yeah, I saw that they had stupid heat. Also, did you see Tampa and Sarasota? My hometown of Sarasota hit 97 today. Their temperature center is literally like 2 miles from the water, if that, and they made 97. And then when the sea breeze kicked in, they dropped from 97 to 89 in an hour.
So that tells me why Grant Gilmore shot a video of himself laying on the beach today. So
pretty much.
There you go. Well, speaking of the beach, how's everything up? Before I get to Shay, because Shay's going to bring in our guest, let's go up to Peter up in the Northeast. Peter, is the heat up there?
Yes, it was 89 today. We just missed 90 degrees. I was very upset. But yeah, it was pretty warm. It was a little bit humid too, but we stayed sunny through much of the day. And then it's going to be another warm day tomorrow. We could hit the low 90s again before a cold front comes in Friday. Gives us maybe a thunderstorm, which probably won't happen. I wish we could, but probably won't. And then the weekend and into next week, we're going to be staying on the cooler side in the 70s, maybe more rain on Monday. But yeah, it's been kind of just quiet and warm and sunny and nice around here. But the pollen is another story, killing us up here. I feel like I'm like choking right now, but you'll see me coughing, I'm sure, during the show. But another good thing, I'm not the farthest panelist up north tonight. You'll see why in a couple minutes.
Yeah,
That is true. Ricky, I'll let you go ahead. And this is something we're going to start doing on the Carolina Weather Group. We're going to bring in some students, some other meteorologists, kind of be guest panelists tonight. So we're kicking off that program tonight. And Ricky, I'll let you introduce our guest panelists, and then we'll give it to Shay for the rest of the show.
We threw out the questionnaire last night on Twitter, and the unfortunate soul who decided to respond to our tweet was Ellie Morrison up from Canada, of all places, our friends up north, coming in clutch for us tonight. So Ellie, tell us a little bit about yourself for people who may not be familiar with you or may not follow you on Twitter.
Thanks. Yeah, so I'm in Toronto. I actually just finished my meteorology degree last month. So to say that I'm done my degree is really exciting. Been fascinated with the weather since middle school. We had a unit on natural disasters, so things like tornadoes, hurricanes, volcanoes, earthquakes, that type of stuff. And it just kind of really clicked then. So for me, it wasn't knowing that 3 or 4 years old. I had no idea at 4 years old what I was going to do. But it was really in middle school in 6th grade that I decided I was going to focus on weather. And since then, I've pursued it.
And you've been someone, you and I have interacted a lot on Twitter and Facebook, and same with Peter. You've really followed a lot of the on-air weather stuff for a long time, some of the modeling stuff for a long time. I mean, really, when you were a kid, you were following a lot of this stuff. So you've talked to me about like Weather Central stuff. A lot of the TV folks will remember that back in the day when we still had Weather Central instead of WSI.
Yeah, I've been into TV graphics a bit just because definitely the area that I want to get into is broadcast met. I really like the idea of being able to do both the science and then communicate it daily with the public. And that's something that I do on my Twitter feed and on my blog. So I really like being in that kind of that bridge between the science and the public.
All right, very cool. Well, feel free to chime in anytime tonight. Let's let us know if you want to butt in the conversation, or just, hey, jump on in and consider yourself a regular panel member tonight. So with that, I'll toss it over to Shay, who's going to bring in our guest for tonight.
Thanks, Ricky. Appreciate it. A little bit about the weather in Charleston. We're getting kind of warm. We had a couple of near record hits last week. I think we got one record up into the mid to upper 90s. And then, man, I'll tell you, we've kind of gone down to the upper 80s. We had 88 today, but the humidity is what's getting us now. So we have a pretty weak subtropical ridge just sort of driving that humidity into the coastline right now. It definitely does make for weaker winds, so we don't expect any winds for several days and just a slim chance of rain each day. So that's kind of the pattern here. I mean, just kind of warm and muggy and waiting for the next wind event to come through or some sort of system to come through. But tonight we have Levi Cowan of Tropical Tidbits. For those of you that are familiar, he has a really good site that a lot of meteorologists use for their needs. And I'm going to just hand it over to you, Levi. Introduce yourself and tell our listeners and watchers who you are, what you do, where you're in school, and a little bit about yourself.
Well, thank you guys very much for having me on. I'm a graduate meteorology student originally from Alaska, came down to Florida State University in Tallahassee, where I'm currently working on my PhD here in tropical meteorology with Bob Hart, who some of you may know. He has a great website, and he'll be lighting it up for the tropics this summer as well. Some of his products and some of his students have worked on some Genesis products as well that are even used at NHC. So a lot of stuff that goes on down here with regard to the tropics. We all love it here. I personally like web design a lot. I started blogging when I was younger in about 2005, followed that crazy hurricane season on Wonderground, where I blogged for a long time, and then decided to move that over to my own little personal web page, which is what I currently run now. And that's been a passion of mine, running model products and whatnot, and blogging and doing data analysis on social media and on that website. And that's kind of my biggest hobby right now is taking care of that little thing. So that's my baby at the moment.
Yeah, so Levi, I'm just sort of going through your website right now. Tell us a little bit about what we can find here. We have forecast models, analysis tools. This is all monitoring ocean sea surface temperatures and anomalies. We have forecast models with a whole suite of models, computer models out there. If you want to kind of elaborate on that just a little bit.
Sure, yeah. So yeah, this homepage here is the blog, which you can see I haven't yet updated since last hurricane season. I'm usually pretty quiet in the off season, so I can focus on school and whatnot. But as soon as we start getting some storms here, as we approach June and the Atlantic hurricane season starts, I usually blog whenever there's activity or potential storms, or especially when storms are threatening land anywhere in the Atlantic basin mostly. I put information up there for current tropical storms. In the tab over from that, anything that's active around the world, you can see forecasts from there's nothing out there right now, which is good news. But when something is there, you'll see tracks and whatnot from models and the official forecast from the National Hurricane Center and JTWC if you're in the Pacific. And I also make recon plots when the hurricane hunters are flying in there. Of course, nothing going on right now. Forecast models are one of my favorite things to deal with. Lots of big data there, very fun to plot. This is meant mostly for the tropics, but there's also some winter products there. You can even see, some snow shading on that default plot for the US. And yes, soundings are a new thing. So I recently added those. You can point and click and get soundings from a couple of models. So it's been a fun project to develop, and there's a lot of stuff there if you want to take a look.
Levi, you mentioned recon plots, and your recon plots have always been a go-to spot whenever there's planes out there. There was I guess there's an advisory from the Hurricane Center over this winter season. They were going to change some of the coding or change some of the layout of that. Does that impact anything?
Yeah, they're called vortex data messages. These are messages that the hurricane hunters send back each time they pass through the eye of a storm or the center of a storm, no matter how strong it is, even if it doesn't have an eye. And it tells you what the strength of the storm is, the pressure at the center, things like temperature, what the maximum wind was measured on the way in. And it usually is sent in a text bulletin style. That style has been the same for many years, but they have recently proposed changes to it, mostly to make information clearer, easier to identify, and including new information that wasn't there before. So the text will change a little bit, and I'll change the programming for some of us who parse those things, but it shouldn't be too bad. It'll just be a few tweaks to the text.
Okay, very cool. Shay?
Yeah, I was going to share screen. Just want to kind of just dive right in. We're talking tropics here, so we're talking Pacific Ocean and Atlantic Ocean. The Pacific Ocean tends to have an effect on Atlantic Ocean with west to east travel or basic travel of weather patterns in general. So I want to go ahead. I want to take a quick peek at the Nino, where what we're looking for is El Nino regions. I sort of just pulled up an image here, and these are regions that of bodies of water of the Pacific that give surface temperatures that kind of give an idea of what we're going to be going into. You hear of El Nino and La Nina and the effects of each one of these have, but it looks like we're going to stay neutral, which is in between those. So Levi, if you want to comment on that.
Sure, yeah, this has been an interesting question since the end of the winter, really. During the winter and the early spring, it was looking like, from dynamical model forecasts at any rate, that we would be going into another El Nino this summer, and perhaps even a rather strong event. And some models still actually do have an El Nino. I know the European model is still pretty warm in its ensemble mean. And this is normally pretty bad for the Atlantic hurricane season in the sense that it's unfavorable for storms. It's good news for all of us, bad news for the storms, because it normally induces a lot of wind shear, which means wind changes very quickly with height, and that is not favorable for hurricane formation. And in general, if there's an El Nino, normally the Atlantic is pretty quiet. It's not a hard and fast rule, but it's a pretty good rule of thumb. And that was expected for most of this winter, but in the last couple of months since March, we've seen a pretty substantial shift toward a cooler forecast in some of the models. The statistical guidance has always been a little bit cooler, but now the dynamical guidance is starting to come down now as well. The image currently on the screen is for mid-April. The mid-May plume should be out within the next couple of days, and that will likely show even cooler lines on that plot, shifted farther down toward that zero line in the middle. And that means that it might not quite be a full-fledged El Nino, or maybe something on the edge, or maybe what you might term a weak El Nino or a warm bias to neutral. It doesn't seem likely to go cold or anything like that. But if it's not a strong El Nino, it leaves the door open for some other possibilities in terms of hurricane activity across the globe, including the Atlantic, where it won't necessarily shut it down as it would if the El Nino was strong. But if it's weaker, or we have a warm bias neutral, you could allow some additional activity that may not have been possible under a strong El Nino. And we've had some seasons in the past which have been strong despite a fairly warm Pacific. Classics, of course, are 2003 and 2004. And 04 was actually hyperactive despite a fairly warm Pacific, but that was the exception to the rule. So it leaves the door open here for a little more uncertainty in the forecast than we thought a couple of months ago.
All right, so we start to talk about sea surface temperatures and how we're going to have to see some effects in the Pacific and in the Atlantic. One thing Michael Lowry posted, and I'll go ahead and share screen again. I know I'm kind of a big fan of sharing screen, but I'm trying to give some visuals for our viewers here. Michael Lowry posted this, and we see the intertropical convergence zone area of the Atlantic off of Africa sort of warming up rather quickly. This is a temperature anomaly where the temperatures are actually rising a little bit above normal. So what do you think about that?
Yeah, this is a great graphic from Michael here, and it's showing how the main development region, what we term the MDR for short, in the eastern tropical Atlantic there, is starting to warm up anomalously. And this is always something we look for at the start of the hurricane season, is whether or not the water where tropical storms typically form in that box there is where a lot of them form from African easterly waves that come off of Africa and move westward from right to left across the Atlantic Ocean. They like to develop in that area, but when the water is warmer, it makes it more favorable for that. If the water is colder, there's less energy available to fuel tropical cyclogenesis and the storms that eventually form there. And here we're seeing it warm up. Now, it is only over a few weeks time frame. We look for this to be persistent on a time scale of months because it can go up and down from week to week. But we are starting to see a lot of models latching on to this area staying warm after the current warm up through at least the next couple of months and into the hurricane season. And that is a favorable sign for hurricane activity, especially when the mid-latitude Atlantic to the north of that black box there is cooling, which it is a little bit now. When you get cold water to the north, warm water to the south, it tends to strengthen what we call the Hadley circulation of the Atlantic, which means air is rising more in the deep tropical part in the low latitudes and then sinking in the mid latitudes, and that tends to promote more thunderstorm activity in the Atlantic tropics, and that's a positive sign for tropical activity during the hurricane season.
Shay and Levi, it really seems like that development region has been lacking over the past couple of years. I can't even remember the last Cape Verde storm we've had that really tracked across the entire area there and into the Caribbean or up to the East Coast. Do you remember which one it was, or do you have any thoughts onto what this season will bring for that area?
Yeah, it's been actually several years. I think the last time we had a pretty active Cape Verde season, those are the years where we have a lot of storms in the eastern Atlantic and the deep tropics. Like you said, the last year we might have had a lot of that activity was 2011. 2010 was the real big one. And then ever since 2011, we've had less than normal activity in the main development region, the deep tropical Atlantic. And that's been due to a number of factors, part of which was the ocean temperature distribution in the Atlantic, where we had the warm water in the wrong place, essentially. So in Lowry's plot that we just saw, we talked about how the warm water, if it's in the deep tropics right there, that's favorable for hurricane formation. But if it's focused to the north, which it was in many of the last several years, it has the opposite effect. So even if there's a lot of warm water, if it's too far north, it falls outside of the typical convective region in the tropical Atlantic, and it therefore does not help as much as if it were in the tropics. So you want that warm water pretty far south if you're looking for hurricane activity, and we haven't really had a lot of that since 2011 in the Atlantic. If that changes this year, then it could indicate that there's a greater chance of some more activity in that region than we've seen in recent years. There is kind of a wild card here, though. And if we're looking at Lowry's plot here, you see that warm ball of anomalously warm SSTs to the east of the eastern seaboard of the United States. That has been a semi-permanent feature also since 2011. And this is a change in the configuration of the Atlantic that we had not seen prior to 2012. And that can be a wild card because, for instance, in 2013, we also started out with a plot like this here, where the tropical Atlantic was warm. That looked like a favorable sign for hurricane activity. But then this warmth around 40 north, east of the eastern seaboard, expanded across the Atlantic in a belt in the mid-latitudes during that hurricane season. And so despite the tropical Atlantic being anomalously warm, there was this belt of warm water in the mid-latitudes as well, and that kind of disrupted the Hadley circulation. And there is something called the Atlantic overturning circulation that was also disrupted that year in the ocean. So the warm water was kind of spilling into the mid-latitudes and messing up where the convection was occurring over a long-term mean over the summer. And what that does is similar to what we talked about with the eastern Atlantic. If the thunderstorms are forming well outside the tropics, it kind of competes with the tropics and doesn't allow as many storms to form on average when you have that configuration. So one of the big questions this year is whether or not that warm ball off of the East Coast expands as it did in 2013 and some other years like 2006, which looked favorable at the beginning of the year, but turned out to be over forecasted.
Are we seeing a trend at all in these locations of these anomalous SSTs, or can it be like a pattern thing, or do we not have enough information to kind of nail that down yet?
Well, the nice thing about ocean temperatures is they are rather persistent. So if you take what we have now, you can expect that it won't radically change over a couple of months. Some things can change, but it's normally what you see in the months prior to the hurricane season often persists for at least the first part of the hurricane season. And then you might have to reassess in July and the beginning of August and see if things have changed then. But what we see now in the Atlantic, that warm ball off the East Coast and the warm MDR, the main development region we talked about, those are likely to persist as long as we see the pattern that we've seen throughout the spring, which right now the models do say will persist through at least July. So we are likely to see a similar setup for the next couple of months.
Well, Levi, talk about a little bit about what you think our season is shaping up to be. I don't think NOAA has come out with theirs yet. I've seen CSR, maybe a couple of other institutions or universities have released their hurricane predictions, but what are you looking at for the Atlantic? I mean, we'll get into the Eastern Pacific in a little bit, but I definitely want to hear your thoughts on the Atlantic season as far as what your opinion might be.
Right. Well, it's been very interesting now with this trend toward a weaker El Nino or perhaps even an end zone neutral summer because this changes a few things. Now, if we have an El Nino or a La Nina, a significant one, that, again, that rule of thumb is very powerful. Normally, an El Nino means a weaker Atlantic hurricane season and a La Nina means a stronger one. When you lose either one of those and it becomes this wishy-washy neutral thing in the Pacific, it means the Pacific is no longer an overwhelming influence on the rest of the global tropics like it is when there's an El Nino or a La Nina. So it leaves the door open for secondary factors to really influence things, such as how the Atlantic is configured in itself, which we just talked about. And in this case, we have a situation where both the tropical Atlantic and the tropical Pacific are warm at the same time. This is not very rare, but it is the least common configuration in the last 50 years. It's only happened 8 times in the last 50 years compared to other configurations where one is cold and the other is warm. And in these cases, it turns out that the Atlantic has had a wide spread of outcomes. So in similar configurations to the one we have now, we've had very weak seasons and we've had very active seasons. Some of the active seasons we had were such seasons as 2003 and 2004, which had a warm Pacific and a warm Atlantic, and the Atlantic had an active year. But we've had other seasons that were much less active, and those usually come down to other details besides El Nino. And when El Nino is not there to help the forecast out, it becomes more difficult. So there's more uncertainty, I think, this year than there would have been if an El Nino was still certain to come on. And of course, it still could. That's one of the big questions, is whether the El Nino starts coming on in the middle of the hurricane season such that the early part isn't feeling a big El Nino effect, but the latter part of the season might start to see some impacts from a developing El Nino if one still does develop. And we do have some models that think that could happen. So that's still a question. If it remains neutral, however, the configuration we're seeing in the Atlantic could support some additional activity. In a situation like this, I would say it's most likely we see something close to a normal hurricane season, which right now is 12 tropical storms, 7 of which become hurricanes, 2 of which become major, is the long-term average. Something not wildly different from that might be likely in this setup, I think. But you could see some deviations to either side of that. If an El Nino develops, you could see a weaker hurricane season like 2009 or 2006, which was one of those that looked favorable at the beginning but turned out not to be so active. But we could also have some seasons like 1990, 1958, where the tropical Atlantic is warm. The Pacific is also warm, but not so warm that it overwhelms the Atlantic with unfavorable wind shear, and you get something more like 12 to 14 storms and above normal ACE, which is a measure of overall activity. So I think something either side of normal is probably most likely, with higher than normal uncertainty in that forecast this year.
Are we getting any better when it comes to forecasting Saharan air layer in advance, or is that really something that's still kind of a nowcasting situation?
That's a really difficult one because there are several factors influencing that. One is African rainfall, and the other is the trade wind strength, which is a function of something called the North Atlantic Oscillation in the Atlantic, which is basically the strength of the Azores high pressure ridge, which is normally in the mid-Atlantic during the summer. There are easterly winds that blow across Northwest Africa and out into the Atlantic on the southern flank of that high. And when that happens, it takes a lot of dust off of the Sahara with it out into the Atlantic. And forecasting that can be a bit problematic months in advance because while the ocean might be fairly easy to predict out to a couple months, the atmosphere often is not. And the ocean can influence the atmosphere, but sometimes the atmosphere just does what it wants. And very often we don't have a good handle on the circulation of the atmosphere around the Atlantic during the upcoming hurricane season. That's still something that's difficult to forecast. We have models, but often they're wrong in that regard, and they're not particularly trustworthy beyond a few weeks in terms of those kind of circulations. So it's hard to say with the dust. A lot of it also depends on tropical wave activity. Not only do the winds off of from the Azores high kick up the dust, but the tropical waves that form over Africa, their strength, their frequency up dust and brings it with their circulations off of Africa westward. And that's often missed, is that tropical waves are always associated with the air layer over the Sahara in which they were born. They bring it with them, usually to their north, as they march west. And even the most active of hurricane seasons will have dust outbreaks. But in some years, such as 2015, those outbreaks can be very severe and detrimental to the hurricane season.
I've always felt that the tropical rainforest section down in Africa, the gradient produced between that and this drier air to the north really kicks those nocturnal jets up and really gets that air elevated up in the atmosphere. So for the viewers out there, the Saharan air layer is a layer of dust that is suspended about 18,000 feet up in the atmosphere, and it drifts across the ocean. Now these waves of dust also pretty much destroy tropical waves as they come off the coast and try to form. It just gets dry air wrapped into it. It's more of a stable environment, and it pretty much kills a lot of the storms that we could be having here in the United States. So it's actually a really big help. So yeah, it should be interesting. I'm wondering if the GOES 16, if it's allocated towards the eastern, if it goes the east, we may have a good shot at seeing some different some panels of that. So yeah, I mean that would be interesting. I've always tried to follow the jetting over Africa to see what the Saharan air layer is going to do, but really all we have is more integrated technology to be able to view that kind of information. So anyways, I think Ricky had a question about the HWRF, some of the modeling, if we want to go ahead and talk about some of the modeling and maybe some improvements and how we're going to be able to see what these systems are going to do.
Yeah, I was curious if there were any changes this year. I swear I saw a tweet, maybe I'm going crazy, which wouldn't surprise me, about some changes in either the GFDL or the HWRF model or some kind of changes this year in those two specific hurricane models.
Yeah, so we actually have a big change coming this year. The GFDL is being retired and is being replaced by a brand new non-hydrostatic hurricane model called the HMON, H-M-O-N. And that's going to be coming out in June, simultaneous with an upgrade to the GFS, the global model that we have here in the United States. Both of those will be coming out, and the HMON represents a model that will be much more skillful than the GFDL, according to hindcasts that have been done. Not as good as the HWRF. The HWRF is still the best hurricane model we have, but the HMON will be a substantial improvement over the GFDL. So hopefully that will add some additional guidance other than HWRF that's able to really simulate the fine details of hurricanes. You hear a lot about the GFS and the ECMWF and these global models. They're not yet high enough resolution to really simulate the fine details of the storms. And that's why we have the HWRF and the GFDL and now the HMON. They're very high resolution models that are able to simulate fine details and give us hopefully some useful guidance to the forecasters at NHC so that they have a better idea of how storms will track and how they will intensify.
What we saw last year, everyone kind of gives the H-warp, I think, a bad name because they see it spit out these crazy solutions sometimes at days 3, 4, and 5. But in the track analysis, it almost had some of the best track analysis and intensity analysis in the short term of last year, correct?
Yes, in fact, it's been one of our best models in recent years, and it's seen very consistent improvement since its inception back in the late 2000s. I think one of the surprises about seeing such good verification after what seemed like pretty bad forecasts during the season comes from the fact that the verifications are done only for forecasts when TCs exist. And a lot of the forecasts we look at are for invests, the disturbances that we track, the storms that either form or never form. And a lot of the forecasts I think that we saw last year and the year before that seemed rather wild were associated with storms that had not formed just yet. In fact, Hermine had a lot of forecasts taking, for example, a Cat 4 east of Florida on the H-WRF and the GFS and a couple of other models prior to Hermine's genesis. Hermine didn't even develop until it got to the Gulf of Mexico. But when it was in the Caribbean and north of the Caribbean and in the Bahamas, we still had models running on it and forecasting it, but it had not formed yet. And those forecasts are not counted in most verification statistics. So you don't normally see those counted. And it's no surprise really because models struggle when you don't have a coherent circulation already developed. If the storm is kind of in its prenatal stage and it's just a baby tropical wave or something, it's often very difficult for the models to latch onto a solution that's stable. And there are often some wildly varying forecasts that you can see there. After the storm actually develops, often you see a stabilization on average where the models start to become a little more consistent with one another and such. Not always true, but often they are. And so you'll see some pretty good forecasts from the H-WRF after storms form most of the time.
Yeah, I saw GFS hit 384 hours. This is, I think, last week, and they had a hurricane hitting us in Charleston. I was like, wow. So, yeah, just always remember these models, especially the longer range model, medium range. The further out you go, the more erroneous they become. So you want to stick with kind of a short range view. But we're kind of entering our way westward. You mentioned the Caribbean. And one question I have for you is the Gulf of Mexico. We have not seen a lot of activity. Last year, we had a little bit of activity. We had, Colin that formed. We had a landfall, Hermine, that formed and made landfall near you in Tallahassee. So that was quite a story. But other than that, the central Gulf of Mexico has been very quiet for several years. Tell us a little bit about your thoughts on that.
Yeah, so this has been part of the shift we've seen in Atlantic hurricane season behavior since 2010, 2011, kind of that time. The last 5 seasons or so have seen both less activity in the typical development regions in the deep tropics, and we've seen less U.S. Hurricane landfall risk than average. And that's actually been going on for the last decade. Since 2005, the U.S. has managed to luck out in avoiding major hurricane landfalls. And we got close with Matthew, but not quite. But it effectively was a major hurricane impact. And this is partly perhaps due to blind luck, but also perhaps due to anecdotally, I've noticed the steering currents have been rather different in the last few years in the Atlantic. We've had, on average, more troughing over the eastern seaboard than normal. That just means that the jet stream dips a little bit farther south and turns these storms northward away from the U.S. before making it far enough west to hit land. And this is coupled with the fact that the storms have been forming at farther northerly latitudes than usual the last few years. And if they form farther north to start, it's much harder for them to get far enough west to hit land before they're already turning away. And so those two things together have been turning a lot of storms away from our coastline, thankfully, for the last decade or so. Why that's occurring could be a number of things. Could be something to do with how much sea ice we're losing in the Arctic in the summer, which is kind of changing how the Atlantic is behaving. Sea surface temperatures are a little different now in the North Atlantic in the summer when the sea ice is very low, and so you can change blocking patterns in that fashion. That's just one possibility. The other is the character that we've had in the Atlantic changing in general. We talked about that warm blob off the eastern seaboard. That was not there before 2012, and that warm blob also changes where the ridging occurs in the Atlantic and can change the average steering currents for storms during the summers, and those are a few factors that could be in play there.
Interesting. So the warm blob off the eastern seaboard, is that in connection with the thermohaline current known as the Gulf Stream? Would it have something to do with maybe a faster current pumping more warm water up into that area?
So I think Phil Klotzbach does a lot of work on this. You talk about the circulation. It's basically how fast warm water is being transported north out of the tropics and how much cold water at the bottom of the ocean is being transported southward. And we've had a few hiccups in that circulation the last few years. 2013 was the most notable one where that circulation slowed down a lot. And what normally happens when the circulation is strong is that you actually get cooler water east of the eastern seaboard, and the Gulf Stream and the water it transports ends up in the far North Atlantic off of Greenland and Iceland and way up in those Arctic latitudes. And then the tropical Atlantic also gets warm. So you get like a belt of warm in the tropics, a belt of cool above that, and then warmth in the Arctic when that thermohaline circulation is strong. When it weakens, you can start getting more the opposite configuration where the warm water starts to bundle up in the subtropical Atlantic in the mid-latitudes and off the eastern seaboard. And I'm not sure if that's responsible for the warm blob we've seen for the last 5 years consistently. We've seen some oscillations around that configuration, but that bubble of warm water off the eastern seaboard has been very, very consistent. And I'm not immediately sure whether it's the thermohaline circulation responsible for that or if it's an ocean atmospheric coupling pattern that's been occurring. Because that can also be the case too, that the atmosphere influences the ocean. If you get persistent ridging over an area of water, it will tend to warm up if the wind speed is low and you're allowing sunshine to warm the water. So that could be another possibility, but it's pretty difficult to know for sure which one of those factors is dominating unless you do, say, a modeling study or something like that.
Interesting. So we'll keep working our way west into the eastern North Pacific. We already had one storm that developed 6 days before the beginning of the Eastern North Pacific or Eastern Pacific hurricane season. That starts May the 15th versus June the 1st because storms tend to start earlier there. But Adrian was unique because it was forecast by the National Hurricane Center to become a Category 1 hurricane and become stationary off of the South Mexican coast. Talk a little bit about Adrian and what that may mean for the season. I mean, it just fizzled out. It was supposed to be a hurricane, fizzled out to nothing within 24-hour period, and then everyone's back onto their normal routine.
Yeah, what an interesting storm to start off the hurricane season. Like kick the rust off, and it's immediately one of the most difficult forecasts I've seen in the East Pac right out of the gate. It's quite something to see. I was fooled too. I thought it was going to strengthen. It looked really good. A lot of the models had it strengthening. The environment looked okay. That was a neat storm because what happened to it was some mid-level shear, and the mid-level shear is harder to find often than the typical wind shear that tilts these storms over and shears them apart. And it was something that was missed by the models, and it was difficult to see in conventional satellite imagery as well. So that storm didn't happen to form, but it was the earliest storm to form in the East Pac, 6 days before the official start on May 15th. And only, I believe, four storms have formed before May 15th, and this was the fifth one and the earliest one of those. And that may or may not mean something for the season. It formed in association with a burst of westerly wind that came across the East Pacific and allowed some spin to develop south of Mexico, and that was a very transient feature. It only lasted a few days. Adrian spun up, and now that area of activity is gone, and it's unclear when we'll get our next shot at a storm there. But this year we do still have a lot of warm water in the central Pacific southeast of Hawaii. And the subtropics have remained very warm. Even if we don't get an El Nino again this summer or a strong one, there's still a lot of warm water to the north of the El Nino region. And that usually means that we'll see a lot of hurricane tracks in the East Pac moving farther to the west and more away from the Mexican coastline. Hopefully, that's usually a good sign for them, is that the storms normally don't move directly north into Mexico when the water is configured this way. No guarantee, but that's hopefully what will happen. The converse to that, though, is that Hawaii may have to worry, like it has the last couple of years, at the chance of a storm getting a little too close for comfort. We've had a couple hit Hawaii in the last couple of years. Fairly rare in historical context, but in recent years, the water around Hawaii has been very warm, and it is again this year. So there's a chance that the Central Pacific may have an active year as well.
Yeah, you're right about that. Yeah, it seems like every year, like you said, the last couple of years, there's been a couple of threats. The storms really come close or come right across the northern or southern sides of the islands, but I haven't seen anything really strong really take a hard hit right down the middle of Hawaii. So they've been pretty lucky. overall. Talk a little bit about your thoughts on teleconnection between the Indian Ocean and Pacific Ocean, because we keep going to the west. I want to see what your thoughts are. We're going to get into what's called the Madden-Julian oscillation, and I wanted you to explain a little bit about that as well. So kind of take it from west to east.
Sure. So the Indian Ocean is interesting. It's normally coupled a little bit with the El Nino variability and the Indian monsoon, which is their annual increase in rainfall as thunderstorms move northward into the Asian subcontinent during May and June and July. And that's starting now. And we keep a close eye on that pre-season because often there's a small relationship usually between the Indian monsoon strength and whether or not we're going to get an El Nino or La Nina during the next 6 to 9 months. If the monsoon is strong, it normally doesn't indicate El Nino formation because it's modifying the Walker cell. It's causing a lot of it's the result of a lot of convection over the Indian Ocean and the maritime subcontinent north of Australia, and that usually indicates that the Central Pacific is not convectively active, that we have strong trade winds due to all the convection in the Western Pacific and the Indian Ocean. And so normally a strong monsoon is a good sign for the Western Pacific, but it is unfavorable for Eastern and Central Pacific El Nino development and strong hurricane seasons in those basins. It has been theorized to influence tropical waves over Africa as well. I'm not as well versed on that literature, but I know there have been some connections that have been made between how strong the Indian monsoon is and tropical waves during the same summer over Africa. So we'll see if there's any connections that can be drawn there, but it normally means a more favorable pattern for the Atlantic in general.
All right. I don't want to keep being the one to ask questions. I do have another question, but if someone else wants to go ahead, Ricky, do you have anything?
So let's kind of talk a little bit about really what, we get all these storms in the early season, and we've seen some homegrown storms in previous years. And this year we had a storm that was really in the far northeast Atlantic. Any correlation to previous years or anything we can take away from that?
From storms in the Northeast Pacific? I'm sorry,
the Northeast Atlantic, with the first named storm we had up there. Anything we can take away from seasons that were more active in the early months?
Right. So actually, there's very little relationship. So like having Tropical Storm Alex last year and now Arlene this year, they really don't mean a lot. And the reason they don't is because they normally form from very different processes than occurred during the peak of the hurricane season. So Alex and Arlene both formed subtropically, which means that they were associated with winter type storms that started sitting in the same spot in the subtropical Atlantic over warmer water and gradually over many days acquired tropical characteristics and eventually transitioned into tropical storms. And in the case of Alex, a full-fledged hurricane. And those storms, since they form from that kind of a different development pathway, it's a very different creature, and it really doesn't tell you anything about the tropical waves that usually come off of Africa and develop during the middle of the summer. It's a very different process. And since the two are unrelated, if you have subtropical storms early in the year, it really doesn't mean anything. Now, what does mean something is if in, say, June and July, we start to see storms developing earlier than usual in the Caribbean or the Central Atlantic or the Bahamas, then that can be a sign that the engine is primed in the Atlantic for activity. So if you start seeing typical tropical development, classic storms developing early in the season, that can be a sign of activity.
Okay. I think Ellie had a question you wanted to ask.
Yeah, so the position that I'm in some of the time, we honestly don't get that much tropical stuff in Toronto because we're a bit too far from the coast. But even when I'm looking at weather for my family along the East Coast, if I am doing a 7-day forecast, I'm not going to spend all my time on the tropical cyclone guidance. And obviously we know that some of the routine models, GFS, Euro, whatever, obviously not the best at handling tropical cyclones, why we have a whole suite of tropical cyclone models. So as a general forecaster, how should I handle writing a general forecast kind of before, during, and after the passage of the tropical cyclone.
You're saying how do you handle impacts inland, or are you saying if you're at the coast?
Like, right, because depending on where the cyclone's position, it could have a totally different wind flow and then totally different temperatures. It's basically a totally different weather scenario compared to what the typical global models may be depicting if they're not in line with the tropical guidance. So it's hard to handle kind of doing routine weather, but kind of before, during, after some nearby tropical cyclone impact.
Okay, I see. So you're saying how a hurricane might influence the pattern as it comes north, either near or east of Canada and that kind of region. It can certainly be very interesting. In the extreme case, we had Hurricane Ida, I believe it was in 2009, bring snow on the backside late in the year in November to the eastern United States and perhaps Canada. I can't remember where exactly they got the snow. And then Sandy had snow on its backside in 2012. It can be very interesting. Hurricanes can cause very strong perturbations in the jet stream and storms around them. Sandy was the most extreme example because it essentially merged with an upper level low over New England. And that was an obviously poorly forecast event originally in the long range, and then in the medium and short range became a very well forecasted event. And they're very interesting situations as far as, general forecasting for them. I think the rules still apply of, using model guidance to your advantage when you know that it's going to be reliable and not prone to errors when a hurricane is present, such as a low resolution global model, which will not do so well when a hurricane is in the pattern. It's less of a problem today than it was 10 years ago by a long shot, because most global models can resolve hurricanes well enough to simulate their impact on the jet stream and everything else around them when they're recurving. So it's all about often ensembles and looking at the range of possibilities, because there's usually a lot of uncertainty with hurricanes in their track and intensity and what have you, and even the model physics and the different solutions that can arise based on the model's representation of thunderstorms. And so all those things come together and cause a lot of different possibilities, and sometimes they're very pronounced. You might have a 2-day forecast that's highly uncertain, and sometimes it's pretty certain and it's pretty consistent, and you don't really have problems until you get out to a day 5 forecast, but it's never always the same, right? So some are worse than others.
And Levi, you brought up a really good point there about steering mechanisms for storms. What sort of things do you look for when it comes to hurricane or tropical cyclone steering, either from aloft in the upper levels or from jet stream, that would be upper levels as well, but even surface features? Tell us, like, what goes through your mind when you see a tropical cyclone, you want to look for steering. What are some of the biggest points you look for?
Right. So tropical cyclones are very much like corks in a stream. They're steered by the average flow along their depth. So if you think about like maybe a short cork in a stream, it's going to follow the water flow near the top of the stream. But if you have this, imagine this like deep cork that actually extends, many inches down into the water. If the stream's water flow is at different directions or different speeds as you go deeper into the stream, then that cork, being a deep cork, is going to feel steering flows at different levels that are different. And so it'll be the average effect of those flows at different depths that steers the cork. It's not going to follow exactly the surface flow, and it won't exactly follow the flow at 10 inches deep. It'll be the average between those. And it's similar with hurricanes. They follow the vertically average steering flow, and that can change based on the hurricane strength. So the hurricane becomes a longer cork as it becomes stronger. So the weak storms are rather shallow. They don't extend very high up into the atmosphere on average. So they're steered mostly by low level flow near the ocean surface and just above, up to about 5,000 or 10,000 feet. And then when you get a major hurricane, it extends very deep throughout the depth of the atmosphere, up to 40 or 50,000 feet. And so it can be steered by winds at a much higher height near where aircraft fly and such. And so you have to be mindful flow is over the entire depth, but also what layer is appropriate for the storm at the given time. And this can be a problem in forecasting, because you might have one model that thinks the storm will stay weak and another model which says it will be strong, but then the tracks are also different. And you might think, well, do the models just have different tracks, or is it because one model has the system stronger than the other and thus is quote unquote feeling the flow at a different height. And those things can become complicated. And so a forecaster has to look at all that and interpret it correctly and try to think about, okay, what level is going to steer the storm primarily? And is it reasonable to assume that the storm will be strong enough to be affected by the airflow at that level? And that's really most of the forecasting for track. There are some other little things that happen with wobbles and other short-term effects. Storms near land can undergo wobbling due to their frictional effects with the coastline because the wind is slowed down more over land than over the water. And you can have wobbles induced by variability within the storm structure itself as well. But in terms of the general track on long time scales, it is all about the vertically averaged flow throughout the storm's depth.
Now, I've heard you say before that smaller, more compact storms have a better chance at surviving a dry air environment over the ocean than a moist environment. So I think we saw that a little bit last year. It seemed like last year was the year of the invests. It was just nonstop. They just kept going and kept going forever and ever. They were supposed to form, then not. And then last minute, all of a sudden, they would get the name. But kind of reiterate on your statement about that. I remember hearing you say that at one point, the smaller, more compact storms in the dry air environment, how are they able to survive?
Well, there's a couple different situations that occur. I think the storm that you're thinking about might have been Danny. It was the one that kind of unexpectedly developed in the MDR. It was in a very dry environment, not forecast to strengthen, and then became a Category 3, sort of out of nowhere. Very tiny storm. The tiny storms have both strengths and weaknesses because, for example, a tropical wave like Danny, as it develops, the tropical wave often forms a protective area of recirculating moist air within which an area of low pressure can begin to grow. And if the low pressure is small and can kind of fit within that moist pocket, then it can sometimes spin up as Danny did and have a better chance of developing than a larger storm that would entrain the dry air immediately around it. However, a small storm is also, in a sense, closer to the dry air than a large storm, because whereas a large storm may have many spiral bands between it and its dry environment, a small storm might have dry air only a few dozen miles away from the eye. So if there's any kind of entrainment at all, the dry air very easily gets to the eye wall and can very easily kill the storm as well. So while a small storm may be able to spin up in a dry environment, if it has just a little bit of a moisture envelope around it, it can also die very quickly to that dry air as well. So it's kind of a give and take there. Both can occur. And large storms have their own problems because even if they're large and they have this giant area of moisture and whatnot, if the circulation is very large, it's harder to spin up. It's the classic analogy with the ice skater bringing her arms in as she spins. If the arms are extended, it's harder to get going faster than if you bring the arms in. The larger the storm, the harder it is to get it to spin quickly. It usually has to become tight and form an eye that is only at most a few dozen miles wide in order to really get going. And so there's a give and take to both those situations, really.
Levi, I got a question for you as we come up with the 9 o'clock hour here. To pivot a little, I was wondering, do you have anything special, anything new rolling out on your website this year that we can look forward to as we look ahead to hurricane season?
Sure. Well, the big thing I came out with a couple months ago was the point-and-click soundings. That's still a pretty new feature. I hope to keep working on those. I do hope to add a few new products to the hurricane model sections this year. I'd like to refresh some of the ocean products, and I'd like to add a few more fields to the tropical regions for this year. I'm working on a couple of ideas. I want to get out a product to deal with subtropical storm formation. I don't have a lot that helps with that, and so I'm hoping to release something like that soon. Haven't had a lot of time to do a lot of coding with school lately, but I'm hoping to roll a couple of things out before the season gets going too quickly here.
Yeah, I do like your forecast GIF that you started. I think you started that at the end of last year, and you're able to actually ask what hours and create an animated GIF and tell it how many frames per second to go. And I've been having a lot of fun with that in the Screencast-O-Matic and doing some editing, and it's really, really useful. That's information you have.
All right, I'm glad you like it.
Too, and like especially in winter when you're trying to show the GFS and how many runs have snow or where the low is tracking and stuff, that's been great for winters.
Let me see if I can get one to run here. bear with me. So I usually like to use just for animated, about 150 frames per second. Let's see if that generates.
That's pretty fast.
Shay, I didn't know you were in the GIF camp as opposed to the GIF camp.
Yeah.
GIF like peanut
I
butter.
always thought GIF was peanut butter.
Okay, that'll work too.
I mean, maybe we should ask the guy who coded it.
It's a never-ending debate. It's like tomato.
Yeah. But anyways, that's just an idea, and you can zoom into regions. You can run different models for it, and it just gives you an idea. The NAM3 is pretty good. I like to use that one, but either way, we won't even get into too many specifics there. But I really like what you've done with your website. Do you have any other talking points you want to bring up about the tropical season coming up before we start to sign off?
Just remind everyone to be prepared. Every year, something can hit you. Always be ready. Every year, please prepare.
Okay. And tell our viewers and listeners how they can find you.
So social media is all Tropical Tidbits. So at Tropical Tidbits on Twitter, Tropical Tidbits on Facebook, and tropicaltidbits.com. All of those places you can contact me and whatnot.
Sounds good. Okay, Scotty, would you like to wrap up the show?
Yeah, we'll wrap up. Thank you, Levi, for coming on tonight. And maybe as we get into the wintertime months, we can kind of have you back on to recap the hurricane season. So, Ricky, I want to, because I think you want to talk a little bit about Canadian weather. So I want to let you kind of ask that and kind of let everyone kind of promote their social media, and then we'll go from there. Because I think you know about next week's show as well. I'm not too sure on it.
Boy, now you're going to put me in the spot and have to remember next week's show. Let me go pull up that schedule.
All it says is race weather. And
that's right. Sure race weather. Doug Snyder's joining us from the Weather Service in Morristown next week. It's been a crazy couple of weeks here, y'all. And I've got contract stuff coming up, and I've got like my lease in my apartment running out, and I'm like, what am I going to do? And come talk to me in the middle of June, and maybe it'll be calmer. Hopefully. But yeah, I did want to give Ellie a chance to plug his social media and just chat a little bit about how weather differs here than up north. This could probably become a whole other show, to be honest with you. But I notice on your Twitter a lot of times you're tweeting out like snow warnings and heavy rain warnings, and it seems like the terminology that's used in Canada is a little different than what we use down here in the United States, correct?
To a certain degree. So I'll start with warning terminology since you brought that up. Rivers and lakes and things like that are handled on a provincial basis rather than a federal basis. So Environment Canada does not have the authority to, or they don't anyway. They won't issue flood warnings. So to kind of get around that, they'll issue heavy rainfall warnings. And the usual criteria for that is usually, I believe it's 2 inches in 24 hours, but I can look that up. But yeah, so basically to get around the issue of not wanting to use the terminology flood warning, they'll use the terminology heavy rainfall warning. We do have snowfall warnings. We have snow squall warnings, which are basically the same thing as lake effect snow. One of the big differences in Canada, which is wonderful from a communications aspect, is we have a watch and we have a warning. We do not, there is no term that has watch, warning, advisory.
Wait, you don't have 122 different warnings and watches and advisories? What do you do with your lives on a daily basis? How do you survive? Totally joking.
No, I get that because I see it all the time down in the States where it's like you have how many different flavors of a wind advisory or a flood advisory?
Yeah.
Way too many.
We have fun.
Some differences. A good thing about Canadian weather is the Canadian model has been upgraded substantially over the last couple of years. So if you have really bad thoughts from 2003, I suggest taking a look at Canadian guidance again, especially the regional Canadian is, at least I find, has been doing pretty well. Definitely does not blow up convectively like the NAM does. I have more trust issues with the NAM sometimes than I do with the Canadian. A big thing here, since I'm in the middle of the Great Lakes, is a lot of mesoscale stuff with the Great Lakes. Often with Toronto right on the shore of Lake Ontario, we get a bit of a lake shadow, so a bit more stability on the north shore of the lake. And so there could be some nasty convection 30 miles to the northwest of Toronto, and by the time it starts kind of slumping southeast, it just falls apart. Lake effect is a big thing in the winter with snow squalls, and especially for commuters coming from the north of Toronto, creates a lot of travel headaches when there's heavy snow squalls. So a lot of mesoscale issues, or mesoscale forecasting in the Great Lakes comes up quite a bit.
You mentioned the Canadian model, and you've always tweeted me sometimes and said, yeah, you know, the Canadian model seems to be doing pretty well. So I want your take on it, and then I want Levi's take on the Canadian model and what he thinks about it too.
Okay, number one, Canadian model do not use for tropical cyclones, period, full stop. Worse than the GFS for that. Canadian global, honestly, at least anecdotally, seems to be about as good as the GFS, because even like in the winter, the GFS has its good days and bad days. The Canadian regional model is a whole different ballgame because it's using boundary conditions from the global model, but then there's a lot more parameterization, subgrid scale processes happening there, and higher resolution. So the Canadian regional model is typically one of my go-tos.
All right, and now I want Levi's take on it.
Well, he said it about the tropics. Don't use the CMC. Don't do it. Nope. It spins up too many storms. You'll get like 9 storms. I don't even have enough fingers for the number of storms it has in the Atlantic sometimes. And it's bizarre. You're right that the regional model does seem a little bit more stable, though I did notice this last winter it seemed to spin up nor'easters way too much, by 10 or 15 millibars compared to other models. I'm not quite sure why, but the Canadian model does seem to have some convective parameterization issues compared to, say, the GFS or the Euro.
It is interesting to watch, though. I think I figured out 1 or 2 triple Fujiwaras last year over the Atlantic. It's a bunch of storms wobbling together, similar to something you'd see in the North Pacific, but definitely not in the Atlantic. But yeah, that's it's interesting to watch. But the CMC does do from time to time. It does do some of the course resolution and wind forecasting pretty well for the southeast region, from what I can see, and even some of the eastern seaboard. Especially the further north you get, the more exact I think it gets as far as the local winds go.
I mean, when you think about it, we're still trying to use a model that's built for almost global forecasting on more. I think we do this a lot with the GFS. We do this a lot with the Euro, and especially the GFS. We try to use it for things it's not designed for. You know, it's designed for global forecasting, and we're trying to make it more for regional forecasting sometimes.
Well, that's where global models are going. They're not going to be just large scale anymore. You got the European model's going to have 9-kilometer runs. And it's like, well, they can almost forecast convection in 10 years, a decade. Who knows what those global models are going to be able to simulate? It's going to be nuts.
So where do we go from there? Do we go to models that are ever run at a high resolution, or do we say, forget high resolution, let's run everything at a lower resolution?
Well, it's interesting. The technique that the U.S., that NCEP is currently employing, is that we're going to ditch the GFS. We're currently in the throes of making a new GFS. We got the blueprints and everything. By 2019 or 2020, we're hoping to have a brand new model, and this model is going to be able to dynamically scale itself. So you might have, say, a grid that's 30 kilometers wide over most of the globe, but then it has the ability to shrink down to really small scales over the United States and any other regions in the Atlantic with hurricanes that we might be interested in, with embedded nests that follow hurricanes around and give you HWRF-like forecasts, but it's still all the same model. And all sorts of ideas like that are being thrown around, where you have this adaptable grid and a unified structure around which you can forecast both global scale things and mesoscale things, all within the same framework with unified model physics and all that. So there's a lot of exciting stuff they're throwing around at NCEP right now. Hopefully we'll see some of that in a few years.
I wonder what Panasonic's model is going to look like and when that's going to come out. I haven't heard anything since the big debut last year.
It'd be interesting to hear more about that. I think they have basically a version of the GFS that they've tweaked a bit. Not sure how they've tweaked it, but that would be interesting to know.
Thousands of soundings per day from every airplane going up. It's got to be pretty good, I would think.
Imagine it can't hurt.
All righty, so guys, I'll wrap everything up here.
Yeah, sure, we will. So, guys, thanks for coming on tonight. We appreciate you being on, and we look forward to seeing everyone next week. We hope you have a great week. Stay cool out there, and hopefully some areas will be able to get some of those evening showers to kind of cool off everyone. So have a great week, and we'll see you next Wednesday.